Okay, hello everyone. So going to go over differentiation, the product rule, the quotient rule and the chain rule, okay? So you all know basic differentiation, which is y equals x dn, and then the product rule is okay. So y equals f. If y equals f if y is a product of f and g are two functions, okay? So y dash equals fg dash, which equals f dash g plus g plus f g dash, okay? So you differentiate f, multiply it with g, and then you add on f times the derivative of g, okay? So that's derivative of f times g plus f times the derivative of g. So you could also write that as df by dx times g plus f times dg by dx. There are lots of different kinds of notation, but they all mean the same thing. So the derivative of x squared sine x, okay? What's that equal to? Well, if you go f equal x squared and g equals sine x, okay? So, as I said, f equals x squared, g equals sine x, so so that equals derivative of this is 2x times sine x, and then plus x squared times derivative of sine x, which is cos x. Okay, so that gives you 2x sine x plus x squared cos x, okay? So that's the derivative of x squared sine x, 2x sine x plus x squared cos x. Okay, next example. So derivative of x cubed cos x, okay? So again, derivative of, you can make either one you want, f, g, it doesn't matter, the outcome's the same. Derivative of x cubed is 3x squared cos x plus the derivative of plus x cubed times minus sine x. Derivative of cos is minus sine, so that equals 3x squared cos x plus minus x cubed sine x, okay? Okay, I could write that out in a more slow form, so if you want, so that equals but dx plus okay, so the derivative of that is 3x squared cos x plus minus x cubed, that's minus x cubed than sine x, okay? Okay, that's writing out the intermediate step. Right, next example. What's this pen like? So, that's too thick. That's too thick. So you got derivative of, the derivative of e to the x is 7, okay? So by the product rule again, derivative of e to the x, I'll take a new sheet of paper, it's a bit easier to work. So that equals derivative of times x to the 7th plus e to the x. Okay? So the derivative of e to the x is e to the x times x to the 7 plus derivative of x to the 7th is 7x to the 6th, so you get, okay, which equals e to the x to the 7 plus 7 e to the x to the 6, okay? So it's nice to write a wee summary actually. I didn't do that here, but it was obvious, but when you got a lot more, I haven't written summaries here, but it's all, we know that that is equal to that, okay? When you got a lot of working, it's nice to write a summary, okay? When you got a lot of working here, so you could write, so therefore derivative of dx x 7th equals e to the x 7 plus 7 e to the x 6, okay? Nice to write a summary. So next, the quotient rule, okay? The function of f of x divided by g of x derivative, okay? That equals f dash g minus f g dash over g squared, okay? So f, a quotient, a function of f divided by a function of g, is equal to the derivative of f times g minus f times the derivative of g divided by g squared, okay? So how do you use this? So you got, if you have y equals x over 1 minus x squared, okay? So f of x equals x, g of x equals 1 minus x squared. I've called them f and g before, I mean f of x, I'll clarify that. So f equals f of x, g equals g of x, okay? It's the same thing. It's just an abbreviation. So the derivative of x is 1 times 1 minus x squared, okay? Minus x times the derivative of this, well, that's 0 minus 2x, okay? So times minus 2x, okay? Divided by 1 minus x squared, okay? So that equals, if you multiply this out, 1 minus x squared, minus times minus is plus 2x squared over 1 minus x squared squared, okay? Which equals minus 1x plus 2x is 1x, so 1 plus x squared over 1 minus x squared squared, okay? Which is the derivative of we wanted, so therefore derivative of dx of x over 1 minus x squared equals 1 plus x squared over 1 minus x squared squared, okay? It's not very easy to simplify this down, so in fact you can't. So that's your solution, okay? Next example. Next example. Right. So y. This is running out of ink. Okay. Okay, so you got so what's the derivative of this? So okay, so that's f, that's g, so it's equal to derivative of this is 1, x derivative of x is 1, derivative of minus 1 is 0, so it's 1 times x plus 1 minus x minus 1 times derivative of this, which is 1, divided by x plus 1 squared, okay? So it's 1 times this minus that times 1 divided by this. Expanding all this, you get x plus 1 minus x plus 1. Okay, so it's all multiplied by 1. So x plus 1 minus x plus 1 divided by x plus 1 squared. So x minus x, they cancel, you get 2 upon x plus 1 squared, okay? So that's the derivative. Therefore, d by dx of x minus 1 over x plus 1 equal 2 upon x plus 1 squared. Okay, that's your derivative. Okay. Right, next, I think we're on to chain rule next. No, maybe not. One more example, trig. So y equals x sine x. So y dash is equal to derivative of that, so it's 1 sine x minus x cos x over sine x squared, okay? So it's x, 1 over sine x minus x cos x. So it equals sine x minus x cos x over sine squared x, okay? Because sine x squared equals sine squared x, okay? So therefore x over d by dx of x sine x equals sine x minus x cos x over sine squared x, okay? So the derivative of x over sine x equals x sine x minus the derivative of x sine x. The derivative of x divided by sine x equals sine x minus x cos x over sine squared x. You can read what I've written. sine x minus x cos x over sine squared x. Okay, sorry for the stumbling with my words. So, right, chain rule. So, okay, so this basic idea is dy by dx equals dy by du times du by dv times dv by dx, okay? So these actually all cancel to leave dy by dx. So you basically are breaking a function down into lots of smaller bits, okay? You have a function within a function and a function and a function and a function, and you take a derivative of each of the subfunctions, and you multiply them all together, you get the derivative of the whole function. That's how it works, okay? So, yeah, you're taking a function of a function of a function of a function, derivative of all the subfunctions, multiply them all together, and you get the whole function. So, if y equals x squared plus 3, okay, cubed, okay, best way to demonstrate, the 3 comes down as normal. You differentiate on the outside first, so 3x squared plus 3, okay. So differentiate the outside, and then you multiply it by the derivative of the inside, which is 2x, okay. So you get, and then by x as well. Derivative of x is 1. So derivative of this is 2x plus 0, and then derivative of x is 1. So you get 2 times 3 is 6, x times x squared plus 3 squared, okay? So that's the derivative of that, okay? Another way of going about doing that is to write, you can write, so write this as y, this is another way, which is a bit more formal. U cubed, u equals x squared plus 3, sorry, u equals v squared plus 3, okay? And v equals x, okay? So derivative y equals 3u squared. Derivative u equals 2v, and derivative v equals 1, okay? So when you multiply all this together, you get y dash equals equals, what am I doing here? It equals okay. So if you multiply it all together, so you get 3u squared times 2v times 1, okay? U was equal to v squared, so and v is equal to x, okay? So you get 3 times 2 is 6 times v squared plus 3 squared, and v, remember, is equal to x, okay? V is equal to x. So this becomes 6x times v squared, 6x times x squared plus 3 squared, okay? Which is what I got originally up here. So I worked out with a more formal way how to work this out, okay? and I come to this answer, which is equal to the original answer, 6x, okay, that's equal to that. 6x times x squared plus 3 in brackets squared, same thing, okay? So this is a more formal way of doing it. So right, another example, if y equals the square root of sine 4x, okay, so that's equal to half, okay, so if you set y equal to the square root of u, and then u equal sine v, and v equals 4x, okay, so cos v and dv by dx equals 4, okay? So if you multiply all this together, you get, sorry, that should be du, not dx. So okay, so when you multiply it all together, I'm sort of expanding what I wrote down originally, but I didn't do that before. So you get half u minus half times cos v times 4, okay, and u is equal to sine v, so you get half sine v, okay, it's minus half times cos v times 4, okay, and v is equal to 4x, so you get half times sine 4x minus half times cos 4x times 4, okay? So this becomes 4 cos 4x, okay, divided by sine 4x, okay, divided by 2, okay, and that goes in twice, so you end up with 2 cos 4x over the square root of sine 4x, okay, so that's the derivative of, so derivative of the square root of, sorry, equals 2 cos 4x over square root of sine 4x, okay? A quicker way of doing it is to do it like this. So again, you start with the outside.